Hi everyone. This short lesson is going to be about the unit circle and trig ratios. So I've got here a diagram. I have a circle of radius 1 and I have a point A which is attached to the circle. So point A must follow the circle as it goes. You can see that this forms a right triangle. There is an angle in here near the origin in the corner of the triangle, and the base of the triangle would equal the x coordinate of point A. The height of the triangle is the y coordinate, which are listed up here. So using traditional sort of middle school maths, the cosine of this angle would be the adjacent side divided by the hypotenuse. But this divided by 1 is just the x coordinate. I can read that there. The cosine of 40.1 degrees is 0.8. The sine would be the opposite side divided by hypotenuse. So that would be the y coordinate. The sine should be 0.6. Now let's get my calculator here and I'll clear some of that stuff away so we can just go for this. I'm on radians, so I'd better change that to be degrees to match my GeoGebra. There we are. So let's try the cosine of 40.1 degrees. Very close to 0.8. I've got this set to display one decimal place only, so it's not too cluttered, but that's there. If I did the sine of 40.1 degrees, 0.6. There we are. Now, you might say, what's the point of doing this? We already know about finding sine and cosine of acute angles, which are inside right triangles. Well, the point is, if we change our focus from the triangle to the coordinates of this point on the circle, we're no longer restricted to acute angles. As we get closer and closer to the top of the circle, my angle here gets closer to 90 degrees, my cosine is getting smaller, and my sine is getting larger. When I hit the top of the circle, the triangle no longer exists, but I do have an angle of 90 degrees, and I do have an x and a y coordinate of this point. So I can now say the cosine of 90 degrees is 0. The sine of 90 degrees is 1. Cosine and sine can be thought of as beyond triangles now. Sine and cosine are coordinates of a point tracing its way around a circle. When I go to a large angle like 120 degrees, go to an obtuse angle here, there we go. So this is one of my special triangles. There would be a 60 degree in this corner. If I want the cosine, I'll need the x coordinate. There it is, negative 0.5. If I check that on my calculator, the cosine of 120 degrees is negative 0.5, just as it's shown here. That point is halfway across to the edge of the circumference there of the circle. What about the y coordinate? Well, if I remember my special triangle, that should be root 3 over 2. So let's try the sine of 120 degrees. Root 3 over 2, which is about 0.9 if I'm looking at the rounded off answers up here. It's around about 0.9. Now, of course, I can go beyond 180 degrees. I can go to reflex angles. I can go all the way around here into the fourth quadrant with these angles as well. These points, this point still has an x and a y coordinate. Even though an angle of 332 degrees could never exist inside a right triangle, I have a central angle, I have a point, the point has coordinates, the point on the circle. So I'm going to say from now on, sine and cosine are coordinates of a point on a circle, not edges of triangle ratios. Okay, thanks for watching.